I'm so honored to be here, and filled with a little bit of emotion because I did have many classes in here, but my time at Amherst many years ago was not that contemplative, actually. And so I really feel like I now teach undergraduates, and I feel like the work that this group is doing is so important. So I'm just really pleased to speak with you, and I've kind of gone native as a scientist, and I sometimes have inscrutable formulations on my slides. So I've tried to translate all of that and make it kind of accessible, because we tend to speak in these really cryptic, jargony phrases. And so if you have any questions, please just shout it out, okay? And but I think I've made this user friendly, and so I'm really anxious for your feedback, and I hope that it is useful for you. Okay, so as Arthur said, we're going to talk about starting with the body and the neuroscience of starting with the body. Can everybody hear me? Yeah. Great. So we have a couple of objectives. I'm going to just describe the neurobiology of mindfulness, and I'm going to focus on the sensory aspects of mindfulness. And then I'm going to talk about the concepts of body space and presence in mindfulness practice. And I'm going to just very briefly describe a hypothesis that we have about the neurobiology of presence and its relevance to contemplative education. So let's start it out. Let's talk about the neurobiology of mindfulness practice. And I take it that many people here are familiar with mindfulness. And so I have a brief discussion of that. But is everybody here familiar with mindfulness or a practitioner? Okay. So one thing that it's gotten a lot of coverage in the popular press, and one thing that we don't hear about is the sort of sensory aspect of the practice, the fact that it's focused on the body. I'm just briefly, the most famous form of mindfulness is the mindfulness-based stress reduction founded by Jon Kabat-Zinn and the Center for Mindfulness at UMass Worcester. So that's sort of the pivot of what I'm going to be talking about today. There's a lot of science on that particular practice, MBSR, and so that's really kind of a good entry point for talking about the neuroscience of mindfulness. So Jon Kabat-Zinn has this famous definition that a purpose of mindfulness training is to teach participants how to pay attention in a particular way, on purpose, in the present moment, and non-judgmentally. And people, this is now seen as somewhat confusing definition to people who haven't undergone the practice. And we can return to that at the end. But I'm going to sort of just tell you that my sense of mindfulness training from taking the MBSR course and from being a practitioner is that there is a primary focus on the body and breath-related sensations, and that the preponderance of the practice is focused on body awareness. Of course, that's the approach taken in the famous sutra, The Four Foundations of Mindfulness, which starts with mindfulness of the body. So in mindfulness training, there are three meditative techniques: the body scan, sitting meditation, and yoga. And one technique that hasn't received as much attention is the body scan. So I'm going to talk about that a little bit in a bit. So as I said, there's a focus on body and breath-related sensations. And one thing that's notable is there's a high level of detail. So the tape starts out, this tape that practitioners listen to, experiencing the big toe in the left foot. And if you can, the little toe, not moving them, but just feeling them individually and perhaps the toes in between. So the question that I have is, we know mindfulness reduces your risk of becoming depressed, it reduces pain, it improves immune function, it preserves working memory, enhances attention, reduces rumination. Why would this instruction do that? So the question is how, and that's sort of what I'm going to talk about. That's the question I'm going to answer today, in a way that I hope is relevant to the larger question of contemplative education. So, as I said, this mindfulness practice is focused on mindfulness of the senses. And it actually encourages practitioners to develop a very subtle awareness of body sensations. We published a qualitative study in our practitioners, and this was one of their sort of practice experience notes. They all had to keep a meditation journal. She wrote, "Nostrils felt very cold when breathing." So that's just a very detailed observation, okay? Why? Why would that be important? For example, how does it reduce the risk of depression? Okay, so that's the first thing I'm going to take on. So what does somatosensory mindfulness do to the brain? So everybody's heard that it helps us pay attention, okay? The question is, pay attention to what? What does that mean, pay attention? Okay, I'm going to describe two attention circuits today that I think are relevant, two brain circuits that are relevant to somatosensory mindfulness, and let's see what you think. First circuit is the lateral prefrontal cortical circuit. It modulates sensory attention. So the translation is, when you pay mindful attention to a sensory stimulus like the breath, you are actually exercising this lateral prefrontal circuit. And that's the lateral prefrontal, those are the lateral prefrontal areas I'm talking about, right there. Okay, these areas are typically described as sort of executive control areas, but one of their sort of primary functions is to help you pay attention to sensations. They also help you with decision making and all sorts of other things, but for now, let's just think of them as sensory attention areas. Yeah. Okay, so there was a really great fMRI study by Norman Farb and Adam Anderson in Toronto. It took place in 2007. And what their study found was that, first of all, the first thing they found was that there are two different brain networks, one that goes up and one that goes down. And this is actually a finding that we've seen in many, many studies. There's the medial prefrontal network, and that is associated with rumination, self-judgment, and self-projection. Yeah.
What do you mean by rumination?
Rumination is negative cognitions, repetitive negative cognitions about the self. Like, I'm not good enough, I can't believe I did that. It can be about events in the past, it can be about future content, or it can just be about the self itself. The main thing is repetitive and negative. It's also thought to be related to entering a depressive state. Okay. So the medial prefrontal cortex sort of coordinates this anxious rumination. It is actually what's called it does a lot of self-related processing. It's incredibly important and useful. If you want to imagine yourself later in the day going and doing your shopping and errands, this is an area that you use. You're projecting yourself into the future. You're planning. It's hugely important. We wouldn't want to lesion it. The problem is that it can get out of control and start to kind of do this kind of runaway ruminative self-processing. And that's what we see in depression and other situations. This is actually a very famous network. It's called the default network. It's where we default. It's where we kind of go to when we're not doing anything else. It's that self-related chatter. Okay? All right, so there's the medial prefrontal network, and then there's this lateral prefrontal network that I've been talking about. That's what coordinates attention to present moment sensations. It turns out that these two networks are what's called anti-correlated. One goes up, the other goes down, like that, okay? And what the Farb group found was that if you ask someone to focus on, let's see, if you ask someone to focus on themselves and judge themselves, like you put a word when they're in the scanner, it says like confident, and you ask them are you confident? Think about whether you're confident. If they do that, then it's this medial network that gets activated. So you notice how this is in the middle of the brain, right there? That's the medial network. Now, if you ask them to focus on what is it like to read that word confident in the present moment, you get the lateral network. Medial, lateral. See how they're like that, okay? All right, so how does mindfulness reduce the risk of depression? It turns out that, let's see, sorry.
Could you speak just a little slower?
Yeah. Okay, thanks. I'm gonna just take a breath.
Will this be available to us?
Yes. Yes. Okay, so it turns out that when you ask somebody to focus on their sensations with a high level of detail, you are taking them out of that medial prefrontal network and you're putting them in this lateral attentional network. And that's what the Farb group found. After mindfulness, I'm not going to walk you through this brain slide, but after mindfulness training, the people who received the mindfulness training had much stronger activations in the lateral prefrontal network during various scanning conditions. Whereas the normal people who had just come in off the street who were, it was randomized, but who were about to take mindfulness but were novices, had medial activations. So mindfulness training helped people shift to this lateral network. Does that make sense?
Yes.
Okay. So, in other words, the lateral network is associated with things like this repetitive cognition, like I spend a great deal of time thinking back over my embarrassing or disappointing moments. That's the type of cognition that mindfulness training reduces. So mindfulness training reduces that kind of cognition and takes you out of that network. And how does it do that? One of the ways that it does that is by asking you to focus on sensation. Focus on the quality of the sensation. Focus on the detail of the sensation. The more sensory detail that you're able to take in a non-judgmental way, the more you're able to get in that lateral network. Okay? And the minute that you go back to that sort of cognitive evaluative loop, you leave that network. Okay? Especially if it's self-related. I've never spoken in the Red Room, and I've been a student here a lot. So it's actually it's great.
I was just reading a book this week by a narrative psychiatrist.
Mm-hmm.
You're talking about the default mode being a storytelling mode, and that rumination being, I did this in the past, oh my God, I did this in the past, and I'm going to do this in the future, I'm going to do this in the future. Is that then?
So, tell me what
the
your
question I have is this, do you see, is this what you see as in the science of it, the sort of the biology of it? From my point of view, it's a storytelling thing.
Yes.
And then if you come out of the storytelling and you get into the present moment, then you're in the sensation mode.
Right.
Is that?
That's it. That's it. And so, storytelling is so important. It's not like we don't want to have this self-related network. That it's a terrible thing when you get lesions in that network. The problem is that it's become so defaulted to that it might have too much power. And what we do see in practitioners is that there's more equivalence. They don't have that anti-correlation, which suggests they're just more in this lateral attentional network all the time. So that's what I'm trying to move into right now. Okay. All right. So that's one way of thinking about the neurobiology of sensory mindfulness. How does this sensory focus help people? How does it within mindfulness training, how does it help them sort of move out of a at risk of depression state and into a healthier mind state? Okay, so that's one neurobiological circuit, this sensory attentional circuit, that is the dorsolateral prefrontal cortex and its connection to other sensory areas. Okay? Yeah.
Does it have to be your own body, or could you be looking at, say, a work of art or something outside yourself?
Oh, any sensory focus. This is not. This is a sensory circuit. So yeah, you could be looking at a painting. The main thing is if you're focused on the sensory details, and you're really attending to the sensory details, then you're in this circuit. And it could be any modality. It could be somatosensory, it could be visual, it could be auditory. But this is when, I think John Kabat-Zinn wrote a book, Coming to Our Senses. I think this is the sort of neurobiology of that idea. Okay. So now I'm going to talk about my experiment. Oh, we're supposed to have an experiential moment. Okay. So focus on the sensations of breathing. We're actually teaching this at Brown Medical School to medical students who are incredibly stressed out. And we're getting them to do 5 and 10-minute mindfulness blocks with this sensory mindfulness. And they say that it's helpful. All right, so the idea here is that, what our hope is that we're moving students from this self-judgment brain circuit to kind of being in this aware, present moment sensory attention circuit. And especially when they get in that ruminative loop, where they're judging themselves and thinking about themselves in the past and the future in a kind of negative way, repetitive way. Our hope is that they can use that moment to move into this sensory network. Okay. So here's the second circuit. This is a little bit less well worked out. The thing I just presented, I think, is pretty true. I'm pretty confident about it. This is more cutting edge, and it actually has to do with work in our lab that we're doing right now. This is the thalamic-cortical circuit. And the idea here is that the thalamus, which is this little piece right here, regulates the sense doors. And that's actually true. There's all of this back and forth conversation between the thalamus and the cortex about what sensations to allow into consciousness. It's called, it gates the sensations, okay? So I think that it's simply true that it regulates the sense doors is one way of thinking about it. So we did an experiment where we used a technique called Magnetoencephalography, which is so see if you can focus on my voice, it's called MEG, and we did it in a copper-lined chamber, and we used superconducting quantum interference devices to focus on the very fine magnetic field of the brain. It's completely non-invasive and just sort of passively records what's going on in the brain. Okay, and the theory here is that what you're learning in the body scan and in breath-related practice is you're learning to regulate the thalamic-cortical neurons. And you're learning that in the body map area of the brain. And this learning, we believe, generalizes across the entire thalamic-cortical landscape. So the body map is up here, but it's the same rules of operation across the entire thalamus to cortex relationship. Okay? So, in other words, the theory is that learning to be mindful of the body teaches you to be mindful of other sensations, thoughts, and feelings, which is, straight out of the 4 foundations of mindfulness. So that's where we got the theory. Okay, so the idea here is that these thalamic-cortical neurons edit sensory stimuli, and they sort of gate unimportant stimuli. And this is the thalamic-cortical circuit from the thalamus to the somatosensory cortex. You're probably familiar with this. This is a map of the body. So if you tap your finger, go like this, then you're activating the primary somatosensory cortex map of the finger in the contralateral hemisphere. So that's happening right now. So you can sort of train your brain just by going like this. But that's a different conversation. All right, so this thalamus to cortex neurons shape sensory stimuli. They shape what you see. And the idea here is that if they didn't, you would be overwhelmed by stimuli. You are flooded with stimuli right now. And you cannot process all of that. You would just be like jelly, basically. And so what do? This thalamus to cortex conversation helps you listen to my voice, and it helps you edit out the sensations in your buttocks. Okay? Which, unless now you're paying attention. But, so if you notice, you can switch back and forth, and that's that sort of being able to work with that thalamic-cortical circuit and being able to amplify sometimes and dampen sometimes. And all of us can do that, but we think that mindfulness enhances the ability to do that. So the way that we looked at this was to look at the alpha rhythm in the primary somatosensory cortex. It turns out that when you have a small alpha, the gate is left open and sensation can come in. And when you have a large alpha, the gate is closed. And it used to be people talked about this as this kind of whole cortex effect. We're looking at it in a 1 square centimeter of the cortex in the body map. We're looking at your ability to modulate this very dynamically, moment to moment. So it's actually kind of a novel approach. Okay, so the idea here is that these...
About that?
Yeah.
So where are you recording the alpha? Is it just from the thalamic?
So no, this is non-invasive. So we're using the MEG to record these faint magnetic fields, and then
The entire surface of the cortex?
the entire surface of the cortex, and then we have these preset algorithms that help us localize to that 1 centimeter square area. And the way we localize actually is we tap the finger, and that's an extremely robust way to localize. And then we look at the area that we find to see if you can kind of regulate it. And I'll talk to you about that in a second.
One more question.
Yeah.
Are you tapping the finger, or the person has to tap their finger themselves?
So we actually have a special mechanical stimulator that's driven by a piezoelectric device that does this incredibly light touch. You can't feel it a third of the time. So it's incredibly light. Actually, to localize, we use a robust stimulus. I mean, we tell it to tap harder. Okay. All right. Does that make sense? All right. So we're measuring alpha rhythms using this MEG, and that's one of our subjects. And the idea here is that, let me tell you a little bit about our experiment, and then I'll tell you the idea. So we have the person sit in this kind of barber chair. The doer, it's called, comes down around the head, and then we have these little tappers. And then we sit outside the room and have a little protocol. There's like automatic schedule of tapping. And there's a cue on the screen, and the screen says, tell me if you were tapped on the foot, or tell me if you were tapped on the hand. And the idea is that in that, and then they sit and wait for like a second and a half. In that period of time, they should be able to either turn the neurons down or turn them up. So if they're paying attention to their hand, they should be able to turn the volume up in the neurons in the hand. And if they're paying attention to their foot, they should be able to turn the volume down. That's the hypothesis. It turns out that normal people can do this in a kind of rough and ready way. What we wanted to see is if we train people in mindfulness, could they do it better? Okay? And the basic idea is that things like the body scan and sitting meditation are this attentional sweep through the body map. And we think that that might be being done to optimize this alpha rhythm control. Does that make sense? All right. So we asked, could practitioners show enhanced control over the alpha rhythm with and just to kind of keep in mind, when the rhythm is little, the volume is turned up. And when the rhythm is high, the volume is turned down. So we looked in the finger map, in the 1 square centimeter area in the finger map, and we found that meditators were better at controlling this rhythm. They were able to control it faster, and in the early period after the cue, they had significantly more differentiation between the hand and the foot. This was after 8 weeks of MBSR training. Okay? Does this make sense? This red line corresponds to the height of that alpha rhythm, and the blue line corresponds to the height of the alpha rhythm. So they either were able to turn the height down or turn it up.
So before you said something about the volume up turns the rhythm up, so I'm getting confused.
It's an inverse correlation, and so sometimes I don't even tell people about the alpha rhythm because it's basically when you have this big alpha rhythm, something's going on there to block out sensation.
Okay.
And when
amplitude goes up, not frequency goes up.
Sorry,
Okay, that's
yeah.
just more-
So it's the height of the height of the wave. Sorry. Yeah, everybody has their own characteristic alpha frequency, but what they tend to do is they either make the height of the wave higher or they make the height of the wave lower. And that's that kind of volume control. Okay? All right. So the result was that meditators were able to achieve earlier modulation of neurons in the hand map, or earlier modulation of neuronal responsiveness. And this sort of is a very preliminary validation of our idea that attention to body sensations may be a useful doorway to mindfulness practice. Just to remind you about our framework, the idea here is that the thalamocortical rules across the cortex are pretty much the same. There's some localized differences, but the way that the thalamus gates and interacts with the cortex is generalizable. So our idea here is that this training in this detailed body sensation mapping that you do in mindfulness may generalize to the rest of the thalamocortical interaction. So the translation here is that better attentional control over these sensory neurons may explain how mindfulness meditators achieve greater control over working memory and are able to more easily regulate cognitions and emotions. So here's the kind of hidden connection that I haven't told you. It turns out that your ability to remember something in a kind of online way, like somebody gives you a phone number, you have to write it down. Your ability to remember that is related to your ability to gate sensations. So what you subtly do is you subtly turn down the volume on these sensory neurons when you're engaging in a working memory task. If you're not good at that, you don't have good working memory.
Could you say that one more time?
Yeah, what you do is you use you turn down the volume on your sensory neurons when you have a working memory task, when you have to hold something in memory briefly. And if you're not good at that, if you're not good at turning your sensory neurons down, if you're not good at dynamically controlling them in that moment, you don't have good working memory. They're correlated. And that's a pretty robust finding now that's been replicated a bunch of times.
Have you done work with people who have dyslexia or ADD, ADHD?
No,
Can you repeat the question?
it's about ADD and dyslexia.
If you work with dyslexics or people with ADD.
No, but I think that this is very relevant to that. And this sensory gating, most cognitive psychologists like to work at the cognitive and emotional level. They don't tend to look at early sensory processing as a kind of precursor to a lot of the maladies that people have. But we do know that in depression and in other disorders, there is a problem with the sensory gating. There's a problem with controlling these thalamic cortical neurons. That's also true in PTSD. So, if you think about PTSD, the whole sensory aspect of it is so important. And so that's what we're trying to this is not sort of in the current conversation, and we're trying to insert this basic sensory processing and attention to sensations, making that part of the conversation. So that's a review that we're writing. We've been invited to write for a journal called Frontiers in Neuroscience, and this is basically a kind of outline of that review. So let me tell you a little bit about the relevance of this, of what I just described to contemplative practice, contemplative higher education. And I'm going to just introduce concepts of body space and presence. Presence you're probably all familiar with. And what I'm going to say is this body space idea may kind of mediate and help us understand a little bit more about presence. So meditators in our study described very subtle body sensations during the body scan. Like I said before, nostrils felt very cold when breathing. They also reported becoming more aware of the inner space of the body, this kind of body space. And this is a sort of a landscape that also has emotional and cognitive sort of memory resonance. And one thing that we found that's really interesting is that when people do the body scan, they report palpable sensations. They actually you kind of feel something when you're scanning your body. So in a way, we think that this is actually learning to feel and train your own cortical rhythms. So there's a kind of phenomenology here. The yogis may have actually known about these cortical dynamics on some intuitive level and been way ahead of us. And we also know that attending to, I think that it's becoming established that attending to body areas may give you more access to emotions. People learn to feel emotions in specific body areas. So we had one kind of journal report, had emotions of anger in pelvic area, happiness in stomach, and sadness to the point of crying in my hands. And that's somebody who's accessing the body space. And I should also add that many of our subjects experienced kind of profound phenomenological change that I was able to witness. So this is the sort of neurobiological idea that we're thinking about. Sweeping the attention through the body space gives practitioners ability to control the volume of neurons, and it confers a kind of attentional freedom. The place where you can see this the most is in chronic pain, where there can be a lack of attentional freedom. People start avoiding light touch sensation. They become unable to tolerate sensations and emotions that arise during the body scan. And I think they have poor control over their alpha rhythms, and their attentional processes are, as a result, may be dysregulated. So that's sort of what happens when you lose the access to the body space. And what I'm suggesting is that loss of access to the body space may be accompanied by a loss of a sense of presence. So attentional freedom, being able to lead the attention through the body space, which is what that body scan is, may have implications for understanding presence. And I'm going to define presence as the ability to rest your mind in the body space without aversion or reactivity. Okay? And we have one finding related to this. we have one subject who had chronic pelvic pain. She was the only subject so far who actually, according to one of our metrics, turned the volume down on the attentional circuit when we asked her to pay attention to her finger. She turned the volume down. All of our other subjects have turned the volume up. Now, this is just a sort of an observation. This is an anecdote at this point. But our hypothesis is that when you enter these kind of chronic pain states or sort of these kind of attentional dysregulated states, you actually can't control these neurons, and there just is this kind of broad dysregulation that sort of ripples out from there. You lose access to the body space. You lose access to that sort of primary sort of emotional, cognitive, reflective space. So the implications for contemplative education, when you sit with other people, sometimes you can feel whether they're present or not. And it may be useful to think of this lack of presence as a kind of attentional avoidance at the level of sensory processing and sensory attention networks. There's just this kind of dysregulation at the level of this primary body map. You know, part of them is sort of numbing out, so it's tuned down when maybe it should be tuned up. And it just ends up with this kind of, what you see on the phenomenological level, people report a very fragmented internal body space experience. So that's sort of the like white whale that we're chasing. And this is the sort of very preliminary data that I'm presenting to you that we're going to have to do in future studies. So just sort of sitting with that for a second and focusing on body sensations, breathing. Now I'm going to give you some more. You're still focused. Okay, so I'm going to just summarize the information that I just gave you. This mindful focus on body sensations may help students learn control over this thalamic-cortical editing mechanism, the alpha rhythm stuff I showed you. This may help them achieve better control over sensory, emotional, and cognitive processes. And then being able to access the body space may facilitate emotion perception and emotion discharge. And it may also teach people how to be present in the body space without reactivity or aversion. So I think that's it. And I want to thank my collaborators who are here. It is a village of people that helped us do this study. So thank you.
Stay there for a moment. I'm sure there's some questions. You've got a whole room full. I'm going to let you.
You mentioned that presence can be being able to be in a body space without aversion or reactivity. Mm-hmm. Is there anything that you would suggest that you are in that space with, or is that going too far? Like, do you hope for people to be there with curiosity or kindness?
Oh, yeah.
Or
so it's interesting. This John Kabat-Zinn's formulation of mindfulness ends with the words non-judgmentally. And I think that first circuit I showed you is actually helpful for understanding that. When you go into a judgmental loop, it becomes very difficult to maintain that sensory focus. So that's why the instruction for curiosity and sensory detail is so important. Because you don't start to manufacture a discourse and ideas about what you're feeling, you just feel it. When you start to get those ideas and judgments, you leave those circuits. You leave that lateral prefrontal circuit.
I was wondering about the door of the senses.
Mm-hmm.
And Quite a long time ago, Virginia Woolf said that most of the time we walk around wrapped in cotton batting. I would say the door is pretty closed so that we're not overwhelmed. And the risk of that is that we don't know how to take it off. But if we were to take it off completely, we would be overwhelmed. So that the regulation of the door seems very important, but also subtle, because I'm thinking about our habitual habits of regulating the senses, which often screen out too much, so that moments of insight or intuition are sometimes actually the allowing of noticing of more that's attempting to come through that door. So I just thought maybe you could say some more about that nuanced relationship.
Well, I think that's why I presented both circuits, because you want to have this attitude of openness and sensory attention, but you don't want to get flooded. And it turns out the brain is set up to do both of those things at the same time. You're training two circuits. If it were just about kind of like throwing open the thalamic cortical doors, you would get flooded, which I guess is a version of what you're saying. So you need to have a lot of discernment that isn't just thoughts, but it's kind of this preconscious setting of like what's important right now in this moment. And that's not sort of a cognitive thing. That's like you walk into a dark room and you sense something. I mean, that's the level we're talking about. Can be very fast, first 100 milliseconds of reaction type thing. And so we're talking about this preconscious ability to coordinate these circuits. And I think this practice is incredibly helpful for doing that. Does that make sense?
That's great.
So I have two questions. The first one is the flooding you're describing. Is another term for that motor overflow? Because that's the term I've heard with ADHD, that you're so flooded with sensation that you can't make sense of what to pay attention to first.
Yes.
So motor overflow is the term that I've heard associated with.
Well, how would you define motor overflow?
That you're so flooded with sensation. So for instance, when you're driving or doing something where you have to pay attention to so many things at one time, that you can't separate out what is more important. Do I check the blind spot, or oh my goodness, what's in the opposite lane? What am I going toward?
So the motor overflow is that you're in a motor task and like you just get a little bit shut down.
Right, or in yoga when you're having to do something really complicated, or move your arms in different directions and your legs in different directions. And kind of having this moment of where do I go, what goes where, and how does it
one thing that's really cool about this alpha rhythm that I presented you is it's actually in a really beautiful relationship with the motor rhythm. And it's incredibly complex. The math is way beyond me, but they're kind of in this like dialogue, the sensory and the motor rhythm, and you need to be able to very quiet, very subtly tune one in order to get optimal control of the other. So in other words, you need to have access to your sensations in order to send commands to move. And it's poorly understood at this point, but one of my colleagues is actually developing a computational model that is very interesting and is relevant not just for meditation, but actually for understanding Parkinson's.
So for learning how to pay attention to...
So the motor processes are completely implicated in this in a way that's very complex. So I think that maybe that motor overflow might be a very rough way of describing that.
And just a very quick comment to the person that mentioned storytelling and that being in rumination. There's a way of meditating during writing where you're paying attention to specific details in the storytelling, so that it's not so much, oh, that was a horrible moment, but I felt this, I saw this, where it's less ruminative and more...
There's actually a study that just came out that's really interesting that points to what you just said.
Do you know?
Yeah, it's by Christoff, Christoff. And what she found was that they're in a structured form of mind wandering, where, by people who are oriented towards creativity, they get both the midline and the lateral network, which is exactly, it's some executive sort of presence, attentional presence that's being maintained to the sort of mental content.
So it's between the two different sides?
Yeah, it's
together?
between the side of the front of the cortex and the middle of the front of the cortex.
Thanks.
And that's that first network that I talked about.
Hi, thank you. I have a comment and two questions, one short, one long. First of all, thank you very much. That was a wonderful presentation, and it gives, I think, a lot of more cachet to the body scan. And many of us, generally invest in it because, those of us who teach tend to say, okay, so now we're moving on to the crown jewel of the practice, which is sitting. We've done this other thing. So thank you for that. And, this person over here was quoting Virginia Woolf. I just wanted to mention something from George Eliot and make a comment and a question on it. George Eliot said that if we could hear the grass grow and the squirrel's heartbeat, we should die of the roar that lies on the other side of silence. As it is, the best of us is well wadded with stupidity. Now, the reason I mention that, besides the fact that I happen to love George Eliot, is that I am aware that, when a person, well, first of all, that meditation presumably takes us into this, greater level of awareness of the grass growing and the squirrel's heartbeat. And perhaps paradoxically, if we come out of a long retreat, we're so oversensitized that, the slightest sound sounds like a roar. So I wanted to just ask you to make a comment on that. And then, so, how do you modulate down after you're so modulated down, and then you return into a world of stimuli? And then I have one other short question.
Okay, I have a colleague named Willoughby Britton.
Yeah, I know Willoughby.
Okay, she can scare the shit out of you. But
she's about 25.
Well, the reason I say that is because she's looking at adverse events after meditation retreats.
Yeah.
And it turns out that that's a really neglected, poorly understood area. It's very important. And so there are definitely examples of people who leave a meditation retreat and just start driving into cars, when they're driving home. And
so like you're driving in the clouds.
So she's sort of actually trying to help places like Spirit Rock develop a protocol for leaving and for check-ins about where you are with all this stuff, because it does have a profound effect on sensory processing. And it, I don't know what the half-life of that is, but we tested some people after a sesshin. One of my students is here, actually. We tested some people after a sesshin, and they had really changed attentional processing and some important parameters. 24 hours after, something like that. It was 24 hours after the sesshin. So I don't know how long that lasts. And I think the phenomenology, the one thing that I'm finding is the phenomenology is a good guide for understanding the time courses of these things. So however long you feel like it is affecting you is probably what's going on in the brain. So.
Okay. So my other quick question is, you mentioned that working memory is very much related to the ability to regulate sensory neurons. Mm-hmm. So I was thinking about, because of my age and my friend's age, a lot about short-term memory issues with some of us who are, a little bit older. And are there implications for short-term memory for greater regulation of sensory neurons? Suppose I practice the body scan instead of sitting every morning. Will I be able to remember?
Actually, I think that I actually didn't mean to restrict this to the body scan. I meant also to be thinking about focusing on breath sensations. So.
Okay, so you weren't specifically talking about body scan.
I kind of was just highlighting the body scan because it is neglected, but I was trying to help us key into that aspect of breath-focused meditation. That it has this really primary sensory component.
Okay, so that's samadhi then, is basically the concentration practices.
In focused on the breath.
Yeah.
Okay. That's a longer conversation. I have to think about there are implications for short-term memory is related to the ability to control these sensory neurons. I haven't seen studies in aging, but I think that a lot of this has implications for aging. Oh yeah, sorry.
A question, it seems that there's a developmental piece to this. For example, both in MBSR and in Vipassana meditation, we talk about a spacious awareness or an open attention, where you're just not cutting off, you're just open to whatever. And it seems like for a brand new meditator, that can be overwhelming. However, for an experienced meditator, at some point, in my own experience, that really opens me up to a deeper sense of compassion with this open awareness. So, I mean, it seems like that might be a future research piece to really tease that out. At what point? Because in teaching MBSR, it's like some people, because I teach MBSR, and some people, when you get to week 5 and it's awareness of thoughts and feelings, some people just throw up their hands. It's like, are you kidding?
Right.
Whereas others can go, wow. You know, and when you open up the open awareness, some people go, wow, and other people go, whoa, too much. And this helps me to understand that there may be a developmental piece to that. There may be an individual personality piece.
Yeah, I think so. I mean, that's what some people say they can't, that they just think some people start out working with cognitions much more readily than other people. So this may have the most implications for people who are resistant to the mind. This is a way to kind of get them into the mind in a really safe way.
Right.
I have a colleague named Jake Davis who's working on what you just said about compassion, and he thinks that there may be a kind of naturalistic relationship between our ability to experience our body sensations. It gives us interoceptive information that helps us be compassionate. There may be a natural, embodied quality to compassion that's universal. Is his idea.
You speak about the ability to edit the stimuli and as connecting to the ability to function with working memory. I wonder if you can extrapolate, speculate at all about maybe some of the sort of the higher kind of liberal artsy sort of qualities of mind that in terms of the ability to hold two contradictory notions at the same time.
Well, working memory would be very important for that. If you can't hold one notion in mind, like I don't know if you know, maybe people are talking, I don't remember, I went through the program pretty closely, but I didn't see this word, but I could be wrong. Metacognition? Yeah, so I think metacognition, the ability to hold in mind that the other person has a different mind, is reliant on working memory, and there is a developmental course to metacognition that's, I think related to working memory capacity. So that would be the one I'd go to first. And the other one's really interesting, but I know that it's intuitively probably true. I just don't know of any science that immediately speaks to it. I'll have to think about it. There should be a neuroscience of paradox. Yeah.
You talked about the positive functions of the medial prefrontal as well. For example, the issue of story and narrative and self. And it seems to me another one is critical thinking, as opposed to judgmental thinking. Critical thinking is what you're involved in right now as you present a scientific study. So I'm interested in the connection between critical thinking and mindfulness, both on a sort of functional level, but also on a brain level, in terms of the two networks.
So this Kalina-Christoph study, I think, is the place to go. In my mind, that's where I answer that, where there's kind of the lateral attentional networks are sort of supervising and in relationship to the medial prefrontal network, so that you don't just go into reverie in a kind of automated fashion, but you're sort of that's
the lateral controls of medial.
Yeah, no, I'm thinking about critical thinking. Well, they're in dialogue with one another. They're usually anti-correlated. That's a very interesting question, and I have to think for a second about, because I went to Amherst, I went to the Humanities Center at Johns Hopkins, so I'm familiar with the term critical thinking. And but I'm not sure how to get a handle on it on a neural level. And I'm sure the medial prefrontal cortex, you need the medial prefrontal cortex at the right level. You need to be able to assess things in a kind of biting way, which is what that area can do. The question is so it doesn't get out of control and sort of start to bite you. But I'm going to think about that. If you send me an email, I'm actually interested in this question. So.
Okay. So it seems what you're presenting us is that by focusing on detailed sensations, we short circuit this rumination factor. I loved your images of the volume control.
Oh.
And what people are often asking me as a teacher of this new practice is, how do I turn down the volume of the thought process?
Yeah.
And I mean, it sounds like you're saying substitute, move the mind to the body or to hearing or to breath, and that will move you out of it. But the question is, there is a way, after a certain amount of practice, that one turns down the volume of the thought process.
I mean, I think you turn down the volume of the thought process right away when you do that.
Right.
And then what happens is you're able to kind of bring that, I mean, the way I think about it is that if this lateral network kind of be on all the time to a certain extent in a slightly different way, then then that might be the developmental piece of the person who's just in this open field of mindfulness. They don't need the sensory object anymore. That would be my speculative answer to what, does that speak to what you're...
Wouldn't that be where we'd want to head eventually?
I mean, that's what the practice tells us.
Yeah.
I don't know about the science piece of it, but I definitely think, I mean, I've been using the practice to set hypotheses, so that would be the hypothesis that I would set. I mean, one thing that's true is that, first of all, not all brain science is true. A lot of it is not true. And some of the practice wisdom may have to be revised slightly, possibly in light of the science. So we just have to be flexible, in both silos. So.
Last question.
You.
I have just a question about, do you have any thought about the way that our increasing use of technology mediates our sensory awareness in particular kinds of ways that influence that capacity?
Well, I mean, there's this Baroness Susan Greenfield in England has been saying that basically Facebook is destroying children's minds. So there is an apocalyptic view that we're overwhelmed by, these devices, and that we're kind of in this always-on state and kind of getting this constant flow of information.
But it's a very, very mediated. So in sensory terms, we're looking at a piece of
right.
pictures behind it.
Yeah, I suppose there is a disembodied quality to it. I mean, one thing that I now am teaching undergraduates, and I think they have a really different relationship to this technology, and I think that their gating, at least at Brown University, is not that bad. And they may be sort of bootstrapping new ways to work with these. I'm not as pessimistic. I think that we're just going through this flooding period, and that there's kind of a learning process that's going on. And unfortunately, for us old people, we're sort of at the back end of that. But young people are going to just have all sorts of ways of kind of controlling this. Does that speak to?
I was just wondering what you noticed. I don't have either or an optimistic focus, but just that sense, since sensory awareness is so important for its regulating function, and it's not that there isn't sensory awareness, but it's shifted.
I think that face-to-face, because the brain is so social, and because the presence of another person is so unpredictable. I mean, they could slap you, they could caress you. I mean, you just don't know what's going to happen. So you have to be like awake. There is something special about that you don't get in an online encounter. So I guess I agree with you that the disembodiment is going to be a sort of a question mark as we move forward.
Thank you very much.
Thanks.